This video is about several things in our solar system. Scientists think that our solar system was formed the same way our planet was. Now, our planet here on Earth, we have a dense inner core, and the lighter things like water and the crust, rock like we have out on the surface, is lighter. So if you take a look at this diagram of our solar system where you have the terrestrial planets here and you have the gas giants here, that's how scientists think it's formed. The stuff in the inner parts, I'll get some red pointing here, the stuff from here in is made of rocks. You know, we have the terrestrial planets here, and that's more dense than gas, which is what these planets are made of here. So that's why scientists think that is the case, why the first four planets are made of rock and the last four planets are made of gas. In fact, if you look at anything out in this gaseous vicinity, like the rings of Saturn, like things that happen to be floating out here, they are mostly ice and, well, maybe a little metal and maybe a little rock, whereas the stuff in here is mostly metal and rock. And that's why. That's why all of this stuff is in here, because it's denser than all the ice and gas that happens to be out there. And that does include the moons of these gas giants. Now, while we're on here, I want to talk about this little area right in here. You can see between Mars and Jupiter there is a bunch of little stuff right here, and that is called the asteroid belt. Now our standards are going to want us to know about asteroids. Asteroids, well here's a picture. Asteroids have a shape that is not really, well, it's not really round, and you can see here it kind of looks, well, like a potato. It has craters, has an irregular shape. They can be up to 600 miles in diameter, so there's some size to these asteroids. 600 miles is like a good sized country or a medium sized country. And most asteroids, scientists think, are in this asteroid belt between Mars and Jupiter. And yes, they are orbiting around the sun, these asteroids in the asteroid belt. There are more than 10,000 asteroids in the asteroid belt, scientists think. But this is a large space, and if you look at it right here, it looks like it'd be hard to get things through here without being hit by an asteroid, and that is just not the case. Even though you have 10,000 asteroids, you have a whole lot of space in between them. Unmanned spacecraft, several unmanned spacecraft have been sent out in this direction, and not a one of them has been hit by an asteroid. They have all passed through without incident from one of these big asteroids. Now these asteroids, they don't have an atmosphere. They don't have a core. So they're not really planet-like unless you get a really, really large one. They're mostly just rock, dust, craters. Since these 10,000 asteroids orbit the sun, it is kind of unlikely that any of these would end up hitting the Earth. But not every asteroid is in this belt, and it's possible for an asteroid to hit the Earth. In fact, scientists think it has happened before. Now, right here you see a comet. I have a little more information on comets here. You can see we're going to talk about comets, we're going to talk about meteors, and you'll need to know the difference between asteroids, comets, and meteors. Comets are small icy objects formed way away from the sun. Now here we have the sun, which is incredibly small for some reason here. If you notice, these comets, they can be way away from the sun, even farther out than like Neptune and Pluto. I mean, look how far these are out. They form way in the dark reaches of space, and they have kind of an irregular orbit. They're orbiting the sun. I mean, look at this red line right here. Look at this green line right here. Even this yellow line right here. They orbit the sun, but they have strange orbital pattern. I mean, all these planets have kind of similar orbital patterns, but that is not the case with these comets. They have a very irregular orbit. They have a tail, and you can see the tail here, but they only have a tail, these ice chunks, they only have a tail when they get close to the sun. So if they happen to be way out here, and I'm not sure why this one has a tail, but if it happens to be way out in the far reaches of the solar system, they do not have a tail. Now here's what happens. This coma, which is what you call a comet without a tail, this coma gets its tail whenever the ice gets closer to the sun, and it kind of burns a little bit of it up and makes kind of misty area. And the reason you see these comets so brightly is because the sun illuminates them. If it's way out in the far reaches, it's not going to be very bright because it is a long way from the sun out there. So that's why you have the lightness of the sun. That's why you have the tail of the sun. So you're looking in my notes to see if there's anything else. Yes, there is more than one tail that can appear on comets. It just seems to work out that way sometimes. And they usually look bright, and the tail is always faced away from the sun. See, this one is faced away. This one is faced away. Now, they shouldn't give comets tails if they're way out and this far away. But all these comets that are nearby would have tails facing away from the sun. Now, very few comets are even noticed by the Earth. There's some that are, but there are very few that are even noticed. Now, let's talk about meteors. Meteors, well, they're space junk. In its route around the sun, the Earth travels at about 70,000 miles per hour. So as it's hurtling through space in its orbit, Earth is going to run into stuff. And Earth is going to constantly collide with little bitty space objects. In fact, some of them are fairly large. And these space objects are what's called meteors. Now, these meteors, in the night sky, they'll streak and have a flash behind them. Sometimes a meteor shower will occur when a comet leaves particles. When a comet leaves particles hit by the Earth, those would often form a meteor shower. And our atmosphere destroys the meteors. But sometimes you have a meteor with a larger mass. And those larger mass meteors sometimes make the Earth's surface. And instead of calling it a meteor, it's called a meteorite if it hits the Earth's surface. Now, these meteorites are usually pretty smooth. This one looks pretty smooth, this one looks pretty smooth, this one doesn't look as smooth. But they usually are pretty smooth from the melting that goes on as it enters the Earth's atmosphere. Oh, their insides may still be frozen once they hit, but they have kind of been molded into a smooth surface on the outside. Most meteors actually have their origins in the asteroid belt, but they're not big enough to orbit the sun. Let's take a look at a few other facts. The closest large galaxy to ours is Andromeda. Now, Andromeda is a galaxy, the Milky Way is a galaxy, and even though it is the closest, it is still very far apart. The light from stars at Andromeda take over 2 million years just to get to us. And that means it's a long, long way. It's hard to fathom the distances in space. Well, by looking at the spectra of light from the galaxies and the star and reading the data that they have gathered, scientists think a couple of different things. They think the same elements are everywhere. You know, we have a bunch of elements here: helium, oxygen, hydrogen, carbon, just to name 4 of 90 or 100 plus elements. Scientists think that those elements are everywhere in the universe. The meteors that we find are not of brand new elements. They're made of the same stuff that we have stuff made of from here. The stuff you find on Mars, the stuff you find on Venus, the stuff you find on the moon. They're made from the same elements. Another thing scientists think is that the universe is expanding, that the universe is getting larger. And they're using the data that they have gotten in something called the Doppler effect, which I'm sure you guys will learn later, has helped them determine that the universe is constantly going out, that it is expanding, it's getting bigger. And that leads scientists to believe that at one point all the universe was contracted into one small area. Now, scientists are speculating that about 14 billion years ago, there was a Big Bang. No, this is not a TV show. But the Big Bang theory is where scientists reason that all matter in the universe was once merged together. Then some kind of big explosion, a Big Bang, if you will, started all the matter to expand. And that's what the Big Bang Theory is. Now, I think we have kind of casually hit on the definitions of heliocentric models and geocentric models. And that is in the standard, so we need to cover this. Now, people on Earth used to believe that the Earth was the center of the solar system because if you look up at night, things appear to move. But we are not the center of the solar system. There is not, the geocentric model is not correct. The heliocentric model is that it doesn't all revolve around Earth. The solar system revolves around the sun. A heliocentric model is like this, where it's all revolved around the sun.